Hi, everybody. Welcome to today's Project Call 9 Proposers Day and teaming event. I'm Scott Miller, Director of Technology at Nextflex, joined by my colleague, Dr. Nick Morris, to whom the lion's share of the credit for putting together Project Call 9 goes. What we'll do today is walk you through information about Project Call 9, including some Nextflex background for anyone who is not already involved with the Institute, the formation of the project call, and then the specific topics. After that, we'll have time for some Q&A, and then we'll move into the teaming event portion in which interested parties will be able to discuss their interest in Project Call 9, in the topics, in building teams and joining teams, and whatever they'd like on those topics. So Jessica, if you could go to the next chart. Or Nick. As we get started here, I just want to make sure that we first acknowledge the federal government for its sponsorship of Nextflex, specifically through our agreement with the Air Force Research Lab, through which all these programs run. And the views that we express here are those of those of us who are presenting and not of the U.S. government. Next slide. All right. In terms of our agenda, we'll talk through various resources for the project call. As I said, our background. I'll talk about the Project Call 9 process and schedule and themes, and then the topics. It's obviously very important to understand the evaluation criteria when you're developing a proposal. And so we'll talk about the evaluation criteria that we use, including changes made for Project Call 9. Then we'll have time for our Q&A and our teaming event. Next slide. So at the risk of sounding like a government presenter presenting an RFP of various types, we'll try to provide you information today, but please refer to the Project Call guidebook and FAQ for the final word on anything. And if there are questions that arise today of a general nature, we will incorporate those into the FAQ online. The guidebook, as it says, is the definitive reference. That's available to all of you on the Project Call 9 website. And you can send us questions after today as well using the email link shown. Next chart. All right, let's go one more ahead. So I'll give you some background on Nextflex as it pertains to Project Call 9. Nextflex is one of the 17 manufacturing innovation institutes, Manufacturing USA institutes across the country that stood up starting in 2012. And have proceeded onward. There's 17 of us now, 9 of which are sponsored by the Department of Defense, like Nextflex, each focusing in a different area of technology and manufacturing, but sharing 3 common goals. The first is to advance manufacturing and technology to full-scale production. The second is to create a robust commercial ecosystem around our technologies. And the third is to secure human capital, to create the workforce that we need for these manufacturing areas to ensure American competitiveness. Next slide. All right. Nextflex is a public-private partnership that was established in 2015 and is headquartered in San Jose, California. We run our consortium with about 100 members across the supply chain. We'll describe what that supply chain looks like and who those members are. We partner with the Department of Defense and other government agencies with more than 70 federal government partner organizations involved. We have 3 nodes in New York, Massachusetts, and Missouri. These are sponsored generally by those states to increase economic competitiveness in their regions. And so for those of you who are located in those states or partnered with organizations in those states, there is, in some cases, opportunity for some additional state cost share to increase the size of your programs and to make them more competitive. We have a number of workforce partners, more than 50 companies and 34 community colleges across the country, as well as more than 100 K-12 school districts through which we work to increase the size of the future STEM workforce by attracting students into STEM career fields. We have a long history of funding projects dating back to 2015. We funded 89 project call projects selected through these project call mechanisms with a total value of $132 million to date at $52 million of funding. Those are augmented by an additional 148 agency-driven projects with a total value of $251 million. So a lot of projects that have gone on. Technology transitions, as you'll hear in our discussion of Project Call 9, are a major focus of PC9, as they have been for every prior project call. And so through these projects, We develop prototypes, we develop at both the system level and the component level, as well as manufacturing processes that can transition. And there have been a number of commercial demos that have been developed. Key outcomes from the projects include things like manufacturing tools, processes, products, prototypes that are sent to DoD and to industry, as well as the integrated knowledge that's generated through these projects. One of the key tenets of project call programs is to benefit all members of the community, so that not just the companies and universities that participate in the project teams. So the delivery of that knowledge is absolutely vital. Knowledge of both what happens in the projects, how it's done, and why it's done is important. Next slide, Nick. So Nexlex defines hybrid electronics as the combination of printed and additively manufactured electronics with discrete components, such as integrated circuits or passives, to create a variety of types of devices. When we stood up the Institute back in 2015, we were focused primarily on flexible devices, flexible hybrid electronic devices that are mechanically flexible as well as stretchable and conformal. And as we've matured the technology and the manufacturing, we've begun to focus an increasing amount on structurally integrated and conformal electronics that are, say, built onto objects and into objects, as well as applications in advanced packaging and heterogeneous integration. And you'll see all of these areas reflected in the topics for PC9. Next slide. Nexlex serves to bring together the ecosystem, and that means the entire ecosystem, from the beginning of the supply chain in areas such as design and materials, out through the equipment that's necessary to provide the manufacturing, and all the way over into OEM areas such as industrial, aerospace, and defense, and medical and wearable devices. We welcome and certainly hope for participation from all the parts of the ecosystem in the projects that we fund, because it strengthens the projects and ultimately strengthens the U.S. manufacturing base for these technologies. Next slide. We have very strong partnerships with Department of Defense and other government agencies, as illustrated by just the logos of some of the government partners that we work with. Our partners in the government side participate in our technical working groups that develop the project call topics, as well as participate in projects and sponsor the agency-driven projects. So government can't be funded directly through the project calls. However, in many cases, they do participate as a partner in projects with some form of self-funding, or perhaps with synergistic programs that they already have running. And so part of the role that Nexlex can play is to make introductions in places where it makes sense, based on the specific proposals that teams come in with. We also bring in government partners very often as technical reviewers for both the proposal process as well as during the execution of the projects to strengthen those bonds even further. Next slide. And this is my last slide, I believe. I wanted to emphasize the importance of targeting proposals that live in the right level of technology and manufacturing readiness. Nexlex core projects, the project calls, focus on TRL and MRLs 4 to 7. Those are the mid-range technology and manufacturing readiness levels. It's not meant to be blue sky research. It's meant for cases where solutions have been developed to a lab state and prototyped at least at the breadboard level, being ready to do that sort of work, taking them all the way out into prototyping for the operational environment and having pilot line manufacturing. So this is the sweet spot for Nexlex projects. It encompasses a very wide range of process development, product development, and manufacturing process development. And so if you have any questions on this, we have resources available on the website, including past presentations and plenty of information available through the Department of Defense. We're also happy to help answer questions that you may have through the pre-submission consultation process or questions that you submit through the email address we provided. Next slide. And Nick, I'll hand it over to you.
All right. Thank you, Scott. Good morning or good afternoon, everyone. So I'm here to walk you through basically the process that got us here in terms of Project Call 9, starting with the technical working groups through the topics and themes for Project Call 9 as you prepare your proposals. So this process really started back last September through our annual road mapping cadence. this is really something that starts within our technical working groups. So if you're not familiar with NextFlex and our technical working groups, we have 11 technical working groups focused on different technology areas within hybrid electronics. 5 of them we call the manufacturing thrust areas. Those are focused on the how of hybrid electronics, really the enabling technologies, things like materials, modeling and design technologies, looking at data generation for standards, test, and reliability. Those are really critical in enabling the adoption of hybrid electronics. There's 6 that we've called the technology platform demonstrators. Those are really more focused on application spaces and markets within hybrid electronics and demonstrate the new capabilities that new electronics form factor and architectures can achieve with hybrid electronics processing. So out of these 11 groups, Scott already mentioned our technology roadmaps. Each one of these groups maintains a 5-year time horizon roadmap in each specific area. And we really tasked the technical working groups over the course of the fall and the beginning of this year to prioritize those technical gaps, look at areas of cross-cutting gaps across the technology areas, and really put effort into addressing how we can affect near-term transition of technologies, as Scott mentioned, as a big thrust, but also make impact to the ecosystem and share knowledge and data among all of our members and government partners. So that's a process that, again, we've been on, our journey we've been on for a while now, and leading up to the topics that you've seen in Project Call 9 or you will see today. So there are 2 versions of those roadmaps that I mentioned. Each one of those 11 technical working groups put out what we call the member benefit version. Those are each around 15 to 20 pages. So there's around 200 total pages of technical roadmap. Those are only available to our members and government partners, and those are available on the member portal. If you don't already have access, please let us know. If you're at least a tier 1 member or government partner, you can have access to those. But several years ago, we also released a public version, which summarizes those full technical versions into a 1-page per technical working group summary. So around 15 pages of total roadmap content. Those are available on our Project Call 9 website. You can find the link there if you haven't already. But this was one of the use cases for that public summary, was really to enable non-members to better align their potential proposals with the Project Call topics. So one of the key evaluation criterion within the Project Call process is alignment to our technical working group roadmaps. So at least giving non-members a snapshot of areas of interest to provide better alignment. We've seen stronger proposals from non-members in those categories. And continuing to update and add functionality and figures to our roadmaps over the years, we've seen stronger proposals from our members as well. So if you need help accessing either of those versions, please let me know. But highly recommend it as you develop your proposals. So in terms of the topic development, as I mentioned, it starts in the working groups. This is started last September as we worked through the developing and prioritizing the gaps. Then this beginning of this year in March and April, each technical working group met to specifically develop topic ideas. Those topic ideas were then taken to our technical council, who prioritized those topics, further refined them, and ultimately made a recommendation of what topics should be included in Project Call 9. That recommendation then went to our governing council, who ultimately approved and selected which topics, given the funding availability, should be in Project Call 9 and to balance the long-term strategy of the Institute. So those are the topics that you see today. In terms of the process as we continue, so the request for proposal, the PC guidebook, was released last week. That has all the information that we're presenting today, much more specific details on both the programmatic and technical details, the evaluation criteria, which I'll touch on. It's basically the Bible for everything you need to know. If there's something in there that you find confusing or information that's missing, again, please reach out to proposal@nextflex.us. Check out the FAQ on the PC9 website, and we'll get your questions answered. The next step after today's Proposers Day is we highly recommend a pre-submission consultation for proposer and proposing teams. That essentially replaces a white paper phase, where this is a chance for you to share your idea, whatever stage it's in terms of a nugget of a proposal idea or a fully fledged project team and really full steam ahead in terms of proposal development. we'd like to hear your idea, provide sort of some instant feedback, potentially recommend some other partners that might add to your proposal. It's really for you to get whatever you need out of a springboard for us to provide information to you that we think would lead to a stronger proposal submission. So you can schedule those now. So email proposal@nextflex.us throughout this proposal development process, and we can get those scheduled. Proposals, once they are submitted, they then go through a peer review process, which will occur in late July and early August. And the peer review process is made up of NextFlex members, members of our technical council, NextFlex staff and subject matter experts, as well as government subject matter experts. That process then, I'll touch on this a little bit later in more detail, but the scoring from the evaluation and comments will then go to our technical council for recommendations of which projects would be funded, and then ultimately our governing council for final selection of funding. So key dates, today is our Proposers Day and Teaming event. Again, you can start submitting requests for a pre-submission consultation. It has next Monday as the first date for that, but if you want, go ahead and send your request and we can fit you in before that, we're happy to do that. But please go ahead and send those in early. Proposal online cover sheets are due 1 week before the proposals are ultimately due. So on July 17th, online cover sheets are due, and that's essentially who your proposal team is, which topic you're proposing to, and just some logistical information about the team itself. That's really mostly for us to internally coordinate reviewers in advance of receiving the proposals. We understand that some of that information might change before the final proposal is ultimately submitted, but that at least helps us coordinate reviewers in advance of receiving proposals. Proposals are ultimately due on July 24th. In the very early release of the guidebook, there was a small typo that mentioned June 24th. Please disregard that. You have a little bit more extra time. You have an extra month based on that, but proposals are due July 24th. And please submit those through the mechanism on the PC9 website. That puts us in terms of allowing for that peer review process throughout the late July and into early August, with an anticipated tech council and governing council review in mid and late September. And that would allow us to potentially let the awardees know in likely beginning part of October in terms of whose projects have been selected for funding, just to give you an idea. So Scott mentioned this, some of these points, so I just wanted to make it clear in terms of the focus of Project Call 9. As this was a member-driven process that came from the technical working groups. It's really focused on addressing critical hybrid electronics manufacturing challenges. And that's been true for the last several project calls now. We really look to enable transition of hybrid electronics into those key applications, continue to drive the performance, especially the reliability, and also improved environmental sustainability, which has been a focus for a few project call cycles now. And Scott really emphasized that we're really looking, especially in Project Call 9, even more than previously, projects that have strong opportunity for technology transition and commercialization into those commercial markets, DoD programs of record, and manufacturing operations. That's a critical need for us as a community to continue to show these transitions. So we're going to emphasize that, continue to emphasize that in Project Call 9. I did mention this is a single stage process, so there is no pre-proposal round, but we do strongly encourage coordination and discussion with NextFlex through those pre-submission consultations. I will highlight, similar to our last project call, PC8, that we do anticipate to fund one or more projects in each of the topic areas. So I'll go through the topics one by one, but there are 6 topic areas, and we do intend to fund at least one project in all of those topics. There could be other outcomes based on the cost and the quality of the proposals that we receive in aggregate, but it is our intent to fund at least one and potentially more in each topic area. Given that there's a clear focus on projects I mentioned for transition, have that near-term commercial impact, industry-led projects that are led by industry or have a strong industry partnership as part of that commercialization plan will be looked upon favorably during the evaluation process, and we can touch on that when we go over the evaluation process itself, as well as proposals that fall within topic areas defined within the DoD critical technology areas. So that's I've provided a link there, and there's a link in the guidebook as well to make sure that they align with those outlined by the DoD. Prior to final granting of the awards, recipients and their partners who are not already NextFlex members are required to become members of the Institute and execute a development agreement. And NextFlex always recommends submissions of future project call topics. So please, if you would like to see different topics, additional topics included in future project calls, please get involved now within our technical working groups. Now is a good time to join. We'll be starting our road mapping process again late this summer. So starting to look forward to our 10th project call early next year. So please get engaged and let us know which topics you think are critical for the next project call. Just a sort of final note there in terms of proposals should build and take advantage of developments from previous project calls where appropriate, not a requirement, but in terms of continuing to mature technologies that have been funded through the project call process, it is encouraged to be able to build on those when available. So looking at what's been done by not necessarily your organization, but the community at large, and continue to build on that success and that progress. In terms of Project Call 9, there are around $5.3 million total available in NextFlex funds, which would put the estimated total project value, if you include cost share for each of those projects, around $11 million. And that's NextFlex funding around between $400,000 and $500,000 per project per topic, which I'll touch on when we go through the topics topic by topic. Most of them are a maximum of $500,000, and topic 9.6 is $400,000. That's the maximum per project per topic. And again, we do anticipate being able to fund more than one project per topic, or up to at least one project per topic, I should say. In terms of period of performance, most of the topics have a maximum of 18 months period of performance. Again, topic 9.6 slightly different with a 12-month maximum period of performance, but we can touch on that when we get to that topic. In terms of the project funding and cost share, so I mentioned that the total we expect Project Call 9 in total to be north of around $11 million. That's with NextFlex funding and cost share. That is because all of the projects that we fund through the Institute's core funds and the project calls do require a minimum of 50% of each project's total cost to be cost share provided by the recipients. So if you're requesting $500,000 in government funds and NextFlex funds, you will need to bring at least $500,000 in cost share. And it's important that that is a 50% minimum cost share requirement per the entire team, not each individual contributor. It is up to the project team to allocate how much each member of the team brings in terms of cost share, but in aggregate, the total team cost share must be north of 50% cost share. That cost share can include a number of things, including labor, materials, use of equipment, travel, cash. There's more information on the PC9 website, within the guidebook and on the PC9 website in terms of what can be counted as cost share. In short, federal dollars cannot be counted as cost share, but other sources of state or local funding can be included as cost share in most cases. So please make sure to reference the documentation or reach out to us if you have any specific questions about what can be included as cost share. I mentioned that to receive NextFlex funding, all team members must be NextFlex members. So they must join by the time they receive funds. The project, while the project is being contracted, they must join at least a tier 1 member. This applies to all subrecipients, project partners, those performing development work. That does not apply to those companies that are just standard suppliers of materials. So commercial off-the-shelf components or materials or services, that is not required for them to join as a NextFlex member, just those receiving development funds. And I'll also note, and Scott mentioned this already, but just to reemphasize, federal government partners cannot receive NextFlex funds. It's not possible for government agencies to receive other types of government funding. but they are allowed and encouraged to support as self-funded participation, self-funded participants. So that's always encouraged. And again, we're happy to do that. So sorry, I mentioned, I said that we needed you needed to join as a tier 1 member. I meant a tier 3 member. So the lowest tier membership is required. So just to be clear. So in general, the Manufacturing USA Institute projects, if you're new to NextFlex, you've never submitted a proposal, you're not familiar with the project call and the type of projects that we fund, it is a different experience and a different type of project than compared to ones you might be familiar with, like SBIRs, STTRs, or from other government agencies like NIH. They are designed to be time-bound and have measurable deliverables with clear performance metrics. So this is specifically focused on maturing technologies, increasing the TRL and MRL. Again, Scott mentioned we can't fund projects that are focused on below TRL or MRL 4. So the object is not specifically product development, but to solve the common gaps that are identified on the roadmaps, to really knowledge share that the data, the knowledge development, the processes developed at a pre-competitive level to really increase the standing of the ecosystem. So it's important to consider that when you're putting these proposals together. So project funding will follow a cost reimbursement mechanism. There's more details within the guidebook. But again, if you have any questions on the specific type of contract and the specific type of projects that are funded, please let us know. So in terms of project objectives and deliverables, I mentioned that they are time-bound and focused on deliverable milestones. They're really focused on developing and qualifying manufacturing processes, methods, or tools identified as areas of needs by the hybrid electronics community. If you're developing software tools, they should be it should include licenses or provisions to allow NextFlex members and NextFlex Institute personnel access. We want to make sure if you're developing these tools that the community can use them to benefit. Projects focused on process development must document that process with enough detail that we can reliably replicate it. We really need to be able to share that information and have it replicated. And there's a number of different types of deliverables that our project call projects take. There's a short list there, but really including data, whether it's raw or processed data. A lot of our members really like to be able to share their data, really like to see the other members' data on materials, processes, performance, reliability. Those are all incredibly important. Flow charts on processing, relevant process information. Test methods are incredibly important as we look towards supporting standards development. How we measure things and advance the TRL and MRL, also incredibly important for transition. Identification of specific tasks or outcomes of the TRL, MRL advancement, and cost model frameworks are highly valuable. And anything we can show in terms of cost modeling is very important to the community. Reliability and standards. It's mentioned in several of the topics themselves. It's mentioned heavily throughout the guidebook, but we really always emphasize the reliability and standards in our topics. So if it's not explicitly mentioned in a topic, it's still globally very important. So any area of your proposal where you can include reliability data that will be generated and disseminated among our community, as well as supporting that data, supporting the development of standards is very important and will be looked upon very favorably. So in terms of the topics themselves, their structure is very similar to how NextFlex project call topics have been for the last several project calls now, back to PC6. They are generally broadly defined topics that include example areas of interest. So the topic itself is around a paragraph or so that describes the requirement for that topic. And then each includes typically around 3 examples of interest that are not requirements, but show a specific area of interest to the community. So really showing those examples, those subtopic examples, the proposals don't need to propose directly to one of those subtopics. They don't need to align. They can align to a part of one of those subtopic examples. It's really just meant to emphasize here is a potential project of interest given some specific metrics that are of interest, but are definitely not requirements. So please take a look at that language. These slides will be available, so please look through this description as well. But the proposals that you submit, they can align with one of those subtopic examples, but they or all or part of one of those examples, but it's not a requirement. So the PC9 topics themselves and the next several charts, I'm going to step through each one of the 6 topics. There's the summary chart, which is included in the guidebook. These are showing you topic 9.1 and 9.6, the topic description, or really the title of each topic, the maximum duration in months. As I mentioned, most of them are 18-month maximum period of performance. The sole defector being 9.6, which is a 12-month maximum effort. Same with funding. 9.1 through 9.5 are $500,000 maximum in NextFlex funding. So a total project with cost share would be north of $1 million total project cost, except for 9.6, which is a $400,000 in NextFlex available funding for that topic, for projects against that topic. And then you can see on the right, alignment with technical working group. We did our best within the technical working groups to at least do some accounting in terms of metrics of where those topics align. I mentioned we have 11 technical working groups. We have 6 topics. We really focused on trying to hit cross-cutting gaps and challenges and areas of need across those 11 technology areas. So we want to do a good job of accounting for where we could see proposals potentially directly aligning with those technical areas, those technical working groups, and indirectly aligning with the X's and O's there. And that's mostly for our metric tracking that we're doing now. But as we select projects and as the development work occurs, we want to continue to track that effort to make sure that we're funding efforts that align with technical working groups, highlighting where we're making those impacts and those cross-cutting themes that we'll be identifying within the topics. So topic 9.1, this is the manufacturing of high-resolution multi-layer packages and devices. So this topic is really focused on a spectrum of size scales, but focused on using additive and hybrid electronics manufacturing processes, focused on multi-layer technologies that can increase the performance, the complexity of either semiconductor packaging at very high resolutions for bare die integration, up to very complex, high layer count, high component count with attached hybrid electronics devices. It includes that proposers are encouraged to do enough test articles to estimate yield, as the goal is to really transition these manufacturing processes to higher volume actual manufacturing scale. So that paragraph there is really the topic description itself, very broad, obviously. But there are 4 subtopic examples that, again, I've only included the titles here. If you go to the guidebook, it has the specific example language and description for each of those. But in short, looking at high resolution direct write interconnects for heterogeneous integration, focus on packaging scale, advanced manufacturing of 3D hybrid electronic devices for very complex hybrid electronic device manufacturing, high layer count, higher throughput manufacturing processes for multi-layer electronics, looking at manufacturing technologies that push the throughput capability, things such as roll-to-roll processing or high-speed sheet-to-sheet assembly and attach, looking to increase the throughput of some of these technologies, and high-frequency RF millimeter wave devices, looking to demonstrate manufacturing techniques, hybrid electronics manufacturing for VWG band, increasing the frequency capacity of these printed electronics. Topic 9.2, this topic is focused on thermal management for power electronics. This one is really focused on the growing need in electronics broadly as we look at either on the packaging scale or the device scale. But as we continue to increase performance and power for these ICs, we bring components closer together and ultimately stack them in 3 dimensions. Being able to dissipate that heat and actively remove the heat from the system is going to be incredibly important. So this is really looking at different methods to either actively or passively remove that heat in these complex 3D structures. Aspects of including multiphysics modeling and experimental validation is highly desired to generate data for the modeling and design areas of our membership and the technical working group, but should not be the focus of this topic, but is a nice to have. So again, those topics that are of interest but are not required are high power modules with additive active cooling schemes, looking at printing heat pipes or channels for active heat removal, things like microfluidics and liquid cooling in high power modules. B, hybrid electronics with high efficiency passive cooling structures. So being able to put passive cooling structures within multi-layer structures, taking advantage of additive processes for optimized geometries of heat pipes, as well as complex 3D printed structures for passive cooling of hybrid electronics devices or packages or devices, I should say, and material solutions for thermal management. So not focusing on the structure possible with additive manufacturing, but more on the materials themselves, thermal interface materials, underfill materials, those thermally conductive dielectrics, potentially phase change materials that can be integrated into a manufacturing process that better remove and dissipate that heat generated from these high power electronics. Topic 9.3 is focused on reliable hybrid electronics for extreme conditions. So extreme environment electronics has been a thrust at NextFlex for a couple of years now. There was a topic in Project Call 8 focused on extreme environments as well. We funded 2 projects that are ongoing in Project Call 8 that focused on higher temperature environments. So one on hypersonics applications, high temperature applications, high shock, as well as one for more on the commercial side, focused on higher temperature, 150, 170 C of repeated cycling. We also funded a project in PC8, a different topic, but focused on very low and very high temperature interconnects. We want to continue to push the bounds of what's possible, demonstrate reliable performance in these extreme conditions. But specific, and those are all still within scope, given the topic description you see there. We list a number of extreme conditions that are of interest, which include high temperature, low temperature, high humidity, thermal shock, high vibrations, G-force, etc. Those are all within scope. But in terms of the examples that we include, we wanted to include some examples that we haven't adequately funded previously that we would like to further explore within the project calls. Again, not a requirement. All of those extreme environments are within scope, but we wanted to highlight 3 areas that are important. The first is evaluation of hybrid electronics for space applications. So space is a growing operational environment for a lot of that we interact with in terms of our DoD partners. There's a growing commercial space business, obviously, as well. But being able to demonstrate that hybrid electronics can reliably perform in this potentially most extreme condition of space, where you have high temperature cycling, rapid thermal shock, ionizing environments, very challenging, the vacuum in terms of materials used. So space is an important environment that we'd like to fund some additional work in. Electronics for high shock and strain, really looking at launchable systems. Those devices or systems that would experience very high shock, very high strain and high strain rate. There's some details in terms of projects of interest in the guidebook, but looking at that as an extreme condition. And high temperature inks from domestic sources. So looking at the materials that are available for those very high temperature applications, typically space or hypersonic applications, where there's considerations in terms of supply chain, national security risk, supply chain risk. So there's details in terms of understanding as part of that project what the availability of domestic sources for those inks are, while focusing the development work on improving and demonstrating some of these key high temperature inks that may not focus on noble metals, but noble metal based inks, looking towards maybe more inexpensive alloys with rare earth metals that continue to hopefully improve the performance, but also the transition potential of very high temperature printed inks. All right, topic 9.4. So 9.4 is conformal and structurally integrated electronics. So when Scott was describing what we describe as we define hybrid electronics as, One of those key areas that we continue to see a lot of growth and potential in is conformal and structurally integrated electronics. So not mechanically flexible, but actually integrating electronics into those complex 3D surfaces, printing on those surfaces directly, or integrating them into very complex form factors. This topic focuses specifically on that. It's really looking to address some of the common challenges associated with that. It's been well known and well discussed within at least our community for several years now. The challenges when you go from printing on a planar surface to printing on complex 3D structures. So this focuses on that, both on the implementation of that, the software, being able to design in 3D, and some of the material challenges as well. So the examples given of particular interest are printed module to module interconnections for wire harness replacement. So on the more system or subsystem level, being able to replace round wire harnesses with printed interconnects directly onto complex 3D body panels for, say, automotive, aerospace, space applications where size and weight requirements are very strict. So reducing the weight of a platform with printed interconnects is very advantageous. That's one example. Improved software tools for printing on complex 3D geometries. This is one where being able to go through the whole design to toolpath generation to print to simulation workflow. It's very tedious right now in terms of the software tools that are available to be able to do that efficiently and effectively. So being able to help and address gaps within that software toolpath or software workflow is of high interest. And the last one is printable dielectric materials for 3D RF devices, looking at new, hopefully commercially available materials or nearly commercially available materials for high frequency applications that are printable and curable on complex geometries at low temperature with UV or other cure methods. Excuse me. All right, topic 9.5. So 9.5 is additive processes for improved environmental sustainability of electronics manufacturing. So if you've looked at the topics, you've also seen that this topic, NextFlex has received dedicated funding from DoD specifically for this topic. So we have around $2 million in project funding dedicated specifically for this topic. And that's based on the need and the opportunity for hybrid electronics to address improved environmental sustainability in electronics manufacturing and address global climate change. And that's what the Department of Defense has dedicated funding specifically for that, for Project Call 9. They did the same thing for Project Call 8. So we funded 2 projects back in Project Call 8 that really focused on looking at the materials used for the conductive and dielectric inks, as well as the substrates used in manufacturing, looking at substrates that are biodegradable or from more sustainable sources, those inks that are, again, recyclable or from water-based solvents, so reducing waste streams. Specifically for 9.5, we really wanted to focus more on the near-term opportunities that exist for adopting hybrid electronics materials manufacturing processes. How do we impact things like the printed circuit board industry? Where there are processes that they can adopt that are hybrid electronics based processes that will greatly reduce the number of processing steps that they use, therefore reducing the amount of energy input, materials used, water, to greatly reduce their footprint, increase their environmental sustainability of their manufacturing flows. That has really the focus of 9.5. Some of the examples included are evaluation of the additive processes for PCB manufacturing. That includes embedded printed passives, so being able to embed resistors, capacitors, or inductors, greatly reducing the number of processing steps, reducing lithography and etch steps, demonstrating a more sustainable manufacturing process. Printed solder masks and conformal coatings, and additive vias, interconnects, and component attach in more traditional PCB manufacturing. Other topics of interest are automated rework and repair of electronics for reduced e-waste generation. So automated approaches to be able to repair electronics to extend their service life, traditional electronics, I should say. So think of a more traditional PCB, being able to repair that maybe trace or replace components using additive approaches to extend service life and reduce e-waste generation. And the same for rework during manufacturing to reduce waste streams, scrap rates, improve yields by being able to do rework in line in a manufacturing flow of more traditional electronics. And C, environmentally sustainable electronics, encapsulants, and overmold materials. So focusing on a class of materials that we haven't previously funded with environmental sustainability funds. So we've previously looked at the inks themselves as well as substrates. Those encapsulants and overmold materials that are more environmentally sustainable is an area that we haven't yet addressed as much. So being able to address that is of interest as well. So let me go to the next slide, and Scott will take over again to explain an opportunity for those that are proposing to topic 9.5.
All right, thanks, Nick. As Nick mentioned, this is the second year of some dedicated funding that we've received from the Department of Defense to support projects related to environmental sustainability and climate change. It's anticipated to be, this year is the second out of what's anticipated to be 3 years of funding for this topic. And because we have this belief there will be a third year of funding next year, we wanted to do something that we have not had a chance to do before with our project calls, and that is to offer the option to propose additional tasks that are not going to be funded, that cannot be selected and funded immediately through the project call 9, but that could be picked up next year through the funding that we anticipate receiving to support this topic in FY25. And so what we're asking that teams do, if they're interested, and it's not a requirement, it's also not a selection criterion, but is to propose additional tasks that would further mature the technologies for transition or commercialization to support those activities. What we're looking for is to have an additional scope described in what is section 10 of the proposal, which is part of the appendices, so that it will describe the work that would be done if selected in this section that must not exceed 2 pages. And then what we'll do, we will be evaluating the execution of any projects that are selected. I'll be monitoring those throughout the execution phase and looking at the potential to pick those additional tasks up for funding during the execution. The idea is that if a project is selected and if those tasks are of interest and if the funding comes in next year as expected, we could go back to the team and seek to contract that work before the PC9 project ends, so that there would be no pause in the funding, and it would advance into those additional tasks for the purpose of increasing the likelihood of technology transitions. This is especially important given that this topic focuses on, ideally, near-term impact in the field. This money from the Department of Defense is meant to drive real impact. It's not long-term research in the same way that some other projects tend to focus on. As Nick described, that's an example of why we're emphasizing areas such as impacting the printed circuit board industry. So as we describe in the guidebook and on the slide here, projects that are selected for award will look at these optional tasks, as we go forward, and are certainly hoping to be able to fund at least some of these optional tasks that get proposed next year. That's it. Nick, back to you.
Thank you, Scott. All right, for the final topic, topic 9.6 is our open topic for new project leads. This is the only one with a slightly reduced maximum funding amount of $400,000 and a reduced 12-month maximum period of performance. So this is a topic that we've had now back to PC6. So this will be the fourth project call that we've included this topic. And the goal and the mission of this topic is really to increase the diversity of new project leads, being able to fund those that have never led a project under a NextFlex PC project, to be able to sort of get their feet wet in terms of what it's like to operate a NextFlex project with a slightly reduced funding amount and likely fewer participants on the project. And we've seen a lot of success over the last 3 or 4 years now in funding these projects that have been led on to those performers to be able to secure additional funding in future project calls in the more traditional topics. So we've seen a lot of success in this. This has very strong support from our technical council and our governing council to be able to continue to increase the diversity of new project leads. We did this year, for the first time in several years, change the eligibility requirement. So we did extend it for additional project calls. So we further restricted who could apply for this topic. So this topic is only open to lead organizations that have not led a project in the last 4 project calls. So back to PC5. So those who have led in 5, 6, 7, or 8 are not eligible for this topic. And that is, again, really the mission is there is to continue to increase the diversity of new project leads. So, given we've funded a number of projects over the last several years, we're really continuing to be able to hopefully bring in new members to the organization, maybe members that have been NextFlex members for a long time now, but haven't led a project, give them the opportunity to be able to lead a project. I also note that organizations, so teaming is strongly encouraged, as with all NextFlex PC projects. And organizations that have led projects in PC5 to PC8 can be project partners, but at least 60% of the NextFlex funding for projects in that category must be allocated to organizations that have not led a project. So hopefully that makes sense, but essentially that if you have led a project since PC5, you cannot lead a project, but you can participate in 9.6 and you can receive funding, but it has to be less than 60%, or 60% of the funding has to go to those that are under that eligibility requirement of not leading since before PC5. I didn't mention the scope of this. It is an open topic. I should highlight there. It doesn't have a specific technology focus area, but it does need to align with the technology roadmaps. So this is where, if you're a member, please look at the member benefit version of the roadmaps. It has all the technical information, the prioritized list of technical gaps. As long as you align with those roadmaps, it will be a topic it will be within scope and of interest. For non-members, this is a great opportunity to check out our public version, our public summary of the roadmaps that still includes areas of emphasis, and so you can still ensure alignment with our roadmap gaps, just not the level of detail available to our members. And again, this is another opportunity where we highly encourage potential proposers to reach out and schedule a pre-submission consultation, because we can help align and hopefully focus your proposal in terms of areas that we know are of high interest to the community. All right. I want to briefly touch on the evaluation criteria, because I think it's important to really emphasize how these proposals will be scored and graded. I mentioned already our peer review process that remains the same since project calls past. Proposals will be distributed to a slate of reviewers, which includes NextFlex members, government subject matter experts, NextFlex staff. On a rare occasion, we may also engage other persons for proposal review, such as third-party subject matter experts. Reviewers evaluate the proposal, score each proposal in several categories, which the evaluation scorecard is included in the guidebook. I have it reproduced on a future slide as well, so you know exactly the scorecard the reviewers will be using. We then collect those scorecards from the reviewers. We compile and analyze the scores themselves, as well as the comments, and we summarize those and present those to our technical council. The technical council then votes on a set of recommendations of which proposals should be funded. That recommendation then goes to our governing council, which votes and selects the projects for award. So here is a very big eye chart in terms of what the scorecard actually looks like. I don't expect you to be able to read that, but it is in Appendix D of the PC9 guidebook, so please take a look. It includes each proposal section, what is expected in each of those proposal sections. There's 14 total now evaluation criteria. This is what Scott mentioned, the change that we've made for PC9 is the addition of an additional criterion. So criterion 8, technology transition potential, because we really want to emphasize the interest in having proposals that have a strong case for transition and a strong commercialization or transition plan. We wanted to add a criterion that specifically calls out technology transitions for reviewers to be able to score. So there's explanation of the criteria here, really describing, is there a clear path for technology transition or commercialization? Does it address a significant need? Are the appropriate stakeholders engaged? Is there a plan to demonstrate that the technology will sufficiently be de-risked? Really getting the proposers to think about their technology transition potential, and including as much detail as they can in its potential in the proposals, so then our reviewers can review that, because that's a huge area of emphasis for us. So please take a look at the new scorecard. Everything else is essentially the same as it has been for the last project call or two. I will call out that the first now 8 criterion that are grouped in what we call the technical merit and transition potential criteria, and then the remainder are the non-technical criteria, which I can discuss on the next slide, how we use those 2 metrics. So I already mentioned we added a new evaluation criteria. I wanted to put a bullet point here and really call that out, that the change this year is really calling out technology transitions. So look at criterion 8. Each proposal will then have a technical score and a non-technical score that are determined by averaging the scores in each of those categories that I showed on the previous slide. Scores from all reviewers produce scores from all reviews produce average scores and a technical ranking. So all of the proposals within a topic are compared to each other, and they have a technical rank. Project selection will rely heavily on the technical score and the relative ranking of the proposals received within a topic. The non-technical score and the feedback that we get from reviewers in terms of the strengths, the weaknesses, is the proposal fundable, are particularly useful to distinguish proposals that are rated closely together in terms of just looking at score alone, as well as identify potential outliers in the review process. Is one reviewer scoring particularly high or particularly low on one or all of the proposals that they review? We take a look at all of that in the analysis that we do. Scores and comments from the reviewers will be compiled, as I mentioned, ranked, prioritized, and then we'll take that to the technical council for their voting on a recommendation. The governing council will also consider input from the reviewers, the technical council recommendation, and other factors, including alignment of the NextFlex dual mission to promote development of U.S. manufacturing for hybrid electronics and support the DoD technology transitions and balance the portfolio of projects that we fund. So all of that goes into the ultimate evaluation and selection of proposals. So, and I think this is really my last slide as a shameless plug of, you should be a PC9 reviewer. So it's incredibly important for our members and our government partners to get engaged. We really want your voice in terms of reviewing the proposals, chiming in on those that we might potentially fund and what their impact would be to the community. So it's vitally important for you to get engaged. It's a benefit of the NextFlex membership to be able to be allowed to participate in the review process and influence what projects move forward. So I want to call out that members cannot serve as a reviewer on a topic in which their organization is proposing. So I understand it's early, projects and potential proposals are still being developed, but go ahead, and if you're interested in being a reviewer on one or more topics, please go ahead and volunteer now. Once we receive all the proposals, once we understand all of the organizations and who the reviewers are, we will go through a process where we remove any potential conflicts. We only allow one industry, academic, or nonprofit or government member to review on each topic. So we can only have one reviewer from each organization from each topic. In most cases, we do allow more than one government organization to participate on a single topic within reason. We really try to strike a balance between industry, academic, and government reviewers across all of the topics. So all the proposals are being read by members from all of those groups, and really get a balanced assessment of the proposals that we receive. We do require that all reviewers be familiar with NextFlex and hybrid electronics, or if there's a particular subject matter expert for one of the topics that would be key to get their voice on, we do enlist those in some cases as well. So please scan that QR code or go to the link, and these slides will be distributed, and you can go to the link. But please sign up to be a reviewer today. It's vitally important to the process. All right. So that's all we have in terms of presenting. So moving forward, we'll happy to take your questions. If you have questions, it will likely look a little bit different. So at least on our side, we have a slightly different look to go to webinar. But if you have any questions, I think some have already entered questions into the question pane. Go ahead and continue to do that. You can also raise your hand, and then we will unmute you, and you can go ahead and answer your question or ask your question. And then if you can't figure out either of those, feel free to email your question to marcom@nextflex.us, and hopefully we can get your question answered. So let me advance one more slide and say, before I forget, anytime throughout this whole process, you have any questions or concerns or want any information, you can reach out to proposal@nextflex.us. And I'll go ahead and leave that QR code up again if you want to volunteer while we answer questions. So, Jessica, do we have any questions? Or Scott, go ahead.
So, Nick, yeah. So I've been fielding some of the questions that have gone in. I think it looks like the default is that it just sends the response back to the person who asked the question. So why don't I read off a few of these so that everyone can benefit from some of the answers. So the first question asked was, will you all have access to the slides? And the answer is yes. You'll get the slides. They'll be posted on the PC9 website, as well as the recording of this webinar. So you can go back and watch and listen to this later on. The next question was, how many awards do we anticipate will be made for PC 9.6? We don't allocate specific funding or a specific number of projects to any particular topic. The exception here being the topic 9.5, for which we received a separately allocated pool of funds from DoD. So that one has its own standalone. Aside from that, the remaining PC9 funds will be distributed amongst the topics based on the strength and quantity of proposals that are received in each of those topics. Question was asked, how can a proposer determine if their organization has led a project out of PC 5 to 8 and are therefore either eligible or not eligible for topic 9.6? Simple answer, email proposal@nextflex.us if you have a question about that, and we will answer it for you. I've actually already answered for the person who asked the question. There was a question about mentioning enough quantity for yield calculations. Can we elaborate on the order of magnitude? I think it's going to be a more nuanced question related to exactly what kind of work is being done. In general, it's not onesie twosies, it's not lab curiosities, it's manufacturable processes. But we're happy to talk with you about during the pre-submission consultation phase about what might be reasonable given the type of project that's being discussed. Just to confirm, TRL, MRL requirements for starting in the 4 to 7 range and ending in the 4 to 7 range is the answer to this question, meaning you have to be at least at TRL and MRL 4, and you cannot go above at TRL and MRL 7. But that does not mean that every project should start at 4 and go to 7. We get a lot of proposals that say that they're going to do that, and my perception, at least, is that that is in some cases, at least, a misunderstanding that that's a requirement that all projects go from one range to the other. Depending on the type of project work that's being done, that may just not be, a possible kind of outcome within the size and scope and time period of these projects. The next question: if funded, who will own any potential IP? The IP policy lays this out very, very clearly. So for all NextFlex members, you have a copy of the IP policy, or at least you can request a new copy of the IP policy. The simple answer is that the developers, the IP policy follows the Bayh-Dole Act. Developers will own their own IP. So that foreground IP developed through a project called Project is termed Institute Developed Intellectual Property, meaning developed at least under partial funding from the Institute. There is a requirement of an evaluation license granted to other NextFlex members, but that is only for internal use purposes and cannot be used for any commercial purposes. And so if another member were to evaluate some IP that was developed and determine that it had value to them, they would have to go and license that IP from the developer. And so ultimately, we believe that this is a benefit to have this, and because it decreases any uncertainty associated with what members learn about the projects that are being done. And it increases the likelihood that these technologies get out into the marketplace without taking away any potential value that the developers can reap from the work that they've done. Can a company participate with multiple teams on different topics? Absolutely. And companies can submit proposals against multiple topics as well. So you could submit a proposal against every topic if you wanted to. You could submit multiple proposals against a single topic if you so chose. At some point, of course, there's a diminishing return in doing that sort of thing, but absolutely building teams and building teams that really cut across different parts of the ecosystem is a really important part of what these project calls do for us. And so, yes, you can certainly participate in multiple teams. Um, is there an option to send a white paper or slide or to have topic reviewed? And is a single university submission with a company co-PI permitted for a project that is 9.5 and new to Nextflex? So two separate questions there. Yes, you can send a white paper or a slide. In fact, what we encourage, it's outlined in the project called Guidebook, the pre-submission consultation process. We have a list of, I believe it's 11 questions that we ask you to answer. They're based on DARPA's Heilmeier Catechism, gently adapted to the kinds of projects that Nextflex focuses on. So we would ask you to fill that out, send it to us at the proposal@nextflex.us address. These are typically maybe a page long. They're meant to be short and very to the point. And if you want to attach a quad chart kind of slide that describes the project that you're conceiving, along with that, that's also very helpful. We'll set up a time. It will be Nick, usually Nick and I, plus we'll bring in others from the Nextflex engineering or fab teams, depending on what the proposal looks like and who we think will help to be able to help answer the question best. And we will provide input on the idea, its alignment against topics. If you're looking for suggestions for potential partners or teaming, we'll provide that as well. And absolutely, proposals from a single member, whether that be industry or academic, are permitted, but I would not encourage that. I would encourage teaming. And so a university with a company PI, co-PI, can be quite a good team. It can be the start of a team, and we can make recommendations for others to participate as well. It's entirely up to you what team you want to put together to submit for your proposal with your proposal.
I'll go ahead and add just for Scott's point on the pre-submission consultation. The questionnaire is in the guidebook and it's in Appendix C if you're looking for it.
Thanks, Nick. All right. So I think I have rapid fire run through answers to all of the questions that were submitted. I'd suggest that we give another minute or so in case anybody has listened to those answers and thought of another question. And if we don't see any more, and actually with this new interface, I'm not sure how to look to see who has their hands raised. So I'm going to try scrolling and assume that still works. Right. Nick or Jessica, I don't know if you see any additional questions.
So we just got one from Mike Mitchell. What's the projected future PCs after 9, 10, 15?
Mike, not sure exactly how you mean that question. We do anticipate Project Call 10 in 2025. Likely, our goal is to have it be earlier in the year than this project call, so likely less than a year between PCs 9 and 10. 9 was later than we wanted it to be because of the timing for the federal budget being done. So PC 8 was launched around end of March. PC 9, we're hoping, or it is obviously now, and PC 10, we're hoping to bring back closer to that kind of a time frame. I do not have a crystal ball that allows me to look farther out than that next year. All right. Given that I don't see any additional questions come in, Nick, I would suggest that we move on to the teaming event. Thank you all for your attention and your questions. And if you have additional questions beyond the end of today's webinar, you can always reach out to us through the proposal@nextflex.us address. That will route to Nick and me and several other people so that we will be able to answer your question in the fastest time possible and minimize the chances that anybody just has it end up getting lost. So please use that address for PC9 related communications. Thanks very much.
Yep. All right. Thanks, Scott. So thank you, everyone. We'll go ahead and start into the teaming event portion of this Proposers Day and teaming event. So we have several presenters that are, this is the opportunity for those that are interested in building out their team, if they're potentially going to lead a proposal, or for those that would like to potentially join a proposal team that's being developed and raise their hand and call out their potential capabilities that they could bring to a team. This is, somewhat of an informal somewhat of a speed dating format where we're giving each of the presenters around a minute or two to be able to present their slide that they've submitted. And then we encourage everyone to reach out if you're interested to the proposers directly. They've included their contact information on their slides if you have questions or you'd like to discuss potential collaboration opportunities. So we're going to move through these. They are divided up by topic. We have some on the front end that are interested in participating in teams in potentially multiple topics. So we'll go ahead and start there and then move through the topics. And those that are sort of on deck, you have an order of the presentations. Please keep an eye on that so you're ready. And you will have to unmute yourself within GoToWebinar when it's your turn to present. And as a final reminder, please try to keep it to a minute or two because we have to get through a number of these. So if you start to go long, I might poke you. So let's go ahead and start with this is those that have had sort of broad interest across a number of the topics we've included, and we're going to start with the Boeing team. So John or team, go ahead.
Hi, Nick. Hi, everyone. I'm John Williams. I'm the lead for Flexible Hybrid Electronics at the Boeing Company. So a little bit of description of our team members. We have a lot of experience with NextFlex. We've worked on project calls from PC2 to PC8, and we've been working pretty much every single year continuously on NextFlex efforts for the past 6 or 7 years. We have a number of in-house capabilities, including an InScript, in which we do 3D printed electronics. We have inkjet printing capability, low temperature solder, die attach, laser patterning. We also do aerosol jet dispense, and we work on everything from about DC to 60 gigahertz. So we can do prototypes with regular PCB boards all the way out to the flexible circuits. We are interested in collaborating with anyone on any project call. We will say 9.1 to 9.5, but if you've got a 9.6 topic and you're very interested and you're new to NextFlex and you want a little bit of help, reach out and call me. So we work on advanced packaging, 3D printed and structurally 3D printed structurally integrated electronics for wiring and reliability of DoD-based applications. We also have a number of devices that we're interested in doing reliability testing and industrialization with, and you can see some of those down below, where we've done high-frequency radars, multi-layer inkjet printed IoT devices. We're doing high temperature packaging and low temperature packaging using like 40 micron traces today. And you can see this 3D printed antenna array that's actually in copper and NinjaFlex and silver and copper ink all merged into one package for doing like a 4x4 BLE device. We've done a large number of applications. Feel free to reach out to either myself, John Williams, or Michael Mitchell at Boeing. Thank you very much. Bye.
All right. Thank you, John. Go on to the next one. So we have the team from Fabricate Labs.
Hi, everyone. Good morning. My name is Anasuya, and I'm the Director of Business Development at Fabricate Labs. We specialized in metal additive manufacturing using a proprietary technique called as electrochemical additive manufacturing, or ECAM. Using this ECAM process, we print high-resolution, pure copper at room temperature. And we can optimize the design for specific applications by using AI generative topology-based softwares. In this project called 9, we are open to collaborate with fellow members on RF devices, thermal management application for power electronics, and also on topic 9.5 that can use our ECAM technology as a vehicle for manufacturing. Given that ECAM is environmentally more sustainable than other additive techniques and also viably scalable, as we are in pilot production facility already. We can print metallic structures directly to printed circuit boards, and we have demonstrated that in project call 8. And because our technique does not require any post-processing, we are less energy and resource intensive. Fabricate Labs has demonstrated that the RF components that we produced by ECAM has 3 dB gain, improved directionality and bandwidth. We have also worked on multiple thermal products, and these have generally shown a 20% improvement in thermal performance and up to 40% lower pressure, depending on the design and the application. So thank you for NextFlex for giving us an opportunity to connect with industry and research pioneers in the microelectronics industry, and we hope for a successful teaming event, and we're open for collaborating. That's it from Fabricate Labs.
All right, thank you, Anu. Next, we have Advanced Printed Electronic Solutions.
Yes, hi. My name is Rich Neal. The company provides AME or 3D printed electronic engineering, product development, R&D, and manufacturing services. We work with a number of system solutions, and in the 3D space, we have a number of infrastructure, including Neotech systems that are 5-axis motion, and also provide a whole bunch of different tool capabilities, ones that will be talked about on the project side here. In terms of the project call, some ideas that we put together here is for the fine line activity. We think there's an opportunity to work on working and collaborating on integrating fine line pitch tooling with existing OEM solutions to implement basically a reference platform for chiplet HI. It could be using a new microsystem or one that's already been developed that needs to, could be mapped to that. On the other project, we're looking at a conformal or a complex 3D geometry for building some kind of application that might be a sensor fusion, according to topic 91B. As far as 94A, there is an opportunity to utilize liquid metal jetting and or wire filament with FFM to develop additive integrated wire harnessing application. So that would be an interesting project to collaborate on. And finally, as a maybe new area, is to look at how interconnects could be formed. We've done some work with curved module connection for male-female. So if you have basically non-planar modules that need to tie into one another, this would address a problem where traditional PCB connectors really can't work because they're designed for planar structures. So that's just kind of the overall in terms of project concepts. Our company capabilities could be, we'd love to work with other folks and offer or contribute to the NextFlex community in the project call 90, and my contact information is in the upper right.
All right, thank you, Rich.
Thank you.
All right, next we have Sunray Scientific.
Hello everyone, this is Isabella from Sunray Scientific. So for those of you who are not familiar with our technology, our flagship technology is an anisotropic conductive epoxy. So basically a blend of ferromagnetic particles and a polymer epoxy. And when it's introduced to a magnetic field, the ferromagnetic particles will align in columns as shown on the diagram. And so our material is basically a replacement for traditional interconnect methods. So replacement for solder, wire bonding, indium bump bonding, as well as others. And so we've previously partnered with a number of you on previous NextFlex project calls, but we're very enthusiastic about partnering and forming strong teams once again. And so the topics that we're interested in partnering include 9.1, 9.2C, thermal solutions, material solutions for thermal management. Our material dissipates heat very well, and so we want to partner with an organization that has an end-use application that we can demonstrate this capability. We're also interested in hybrid electronics for space systems, as our material has undergone, we know it has very good rad-hard capabilities. We're also interested in 9.4A as well as 9.5, but this list is not comprehensive. If anyone else needs a robust interconnect solution, we would be enthusiastic to partner as well.
All right, thank you so much, Isabella. All right. Well, now we'll go ahead and move into those that express specific interest in at least one of the topics. Obviously, some of them describe interest in other topics as well, but this is the one for 9.1, manufacturing of high-resolution multi-layer packages and devices. And we will start with Nano Dimension.
Hi, everybody. My name's Matt Winch. I'm one of the aerospace defense and government business development folks here. And actually, we kind of really apply to all of them. 9.1 makes the most sense because we have an actual 3D printer that prints dielectric and conductive material simultaneously. And we can do a whole lot of things that really are a lot of the topic areas that are being discussed. In particular, we're showing multi-layer here, on that, ability we can print upwards of 60 layers of, capacitor. That's what that one over there on the multi-layer PCB on the right is. But we also do interposers. We can do RF stuff. We can do prototyping, we do SIP, we do, things that are ranging really anywhere from a 3-4 level all the way up to, 6, 7, and 8, depending on what you want to do, antennas, etc. We are a machine provider. We're interested in, helping people out who have a specific topic or a specific item that they would like to investigate. Our Dragonfly is ready to go. In addition to that, we also have a lot of advanced software tools for doing 3D design, which may be another topic area that we could talk about directly. We also have printed microplastics that can be metallized as well, which is a potential antenna application. And then, one of the areas that we're also actually really strong in, and I don't have it on this slide, is the whole environmental impacts. And we've actually quantified some of that in terms of the reduction in CO2 and water usage and electricity, whole lot of things. And I realize I don't have my contact information on this slide. So Nick and Scott, if you guys would be willing to, if someone's interested in getting in touch with us, please share mine. And actually my colleague Justin Mattern is on the call as well. If you could share our information if somebody comes back, I'd appreciate it.
Yep, happy to do that.
Thank you.
If you want to provide an updated slide, we can put it in the version that goes up on the website, so it's there for readers.
Okay, yeah, I'll try to get that out to you guys shortly.
Yep, thanks, Matt. All right, let's move on to Terra Circuits.
All right, so yeah, I do have some animations in there, so you can just click through. That should be about the end. So I'm Michelle from Terra Circuits Corporation. We specialize in materials for semiconductor advanced packaging. One of our technologies that we think could be a good fit for topic 9.1 is a cleanly decomposable polymer for mass transfer of small, thin, and fragile components. So this is something we specialize in: stimuli responsive materials that can be activated by heat or light to assemble and release small components through space with no chemical residue left behind for precision placement and assembly. So some application spaces for this would be like high resolution micro LED displays where we have really tiny components, or thin and fragile silicon based components for integration into flexible hybrid electronics for those types of components that you want to be very thin so they're flexible but you can't directly print. So yeah, we're interested in partnering with anyone who needs a high throughput assembly solution for these types of components that are not readily handled by pick and place or other conventional assembly techniques. We do also have another technology that we are developing, which is a nanoparticle filled epoxy with tunable CTE for underfill. So this is something that could apply to 9.2 or 9.3 for the thermal management, or for major temperature swings in some type of application where you have a device that you need to be reliable under those conditions. So this is something else we're working on developing, and we'd be happy to partner with anyone who needs a solution for those extreme temperature swing kind of conditions, or those who have the ability to do the thermomechanical type testing that would be required for this type of material. So if you have any interest in either of these technologies, feel free to reach out to me. My contact info is in the bottom left there. Thank you.
Thank you, Michelle. Oops. All right, next we have Auburn University.
Hi, my name is Pradeep Lal. I'm a professor here at Auburn University. So we are planning to lead a project in the topic area 9.1, general focus being on additively manufactured 3D hybrid electronic devices with a focus on multifunctional prototype devices with integrated high I/O components and passives that would be integrated additively into the final structure and optimized for electronic performance and reliability. So what we hope to be able to do is leverage a significant body of our prior work in PC 6.4, in which we did assembly of devices for NextFlex, and 6.5, in which we developed process controls for printing of various passives, and a currently ongoing program PCA2, which uses high temperature capability of integrated devices themselves. So in terms of exemplars, some of those are shown on the right hand side. Top right kind of shows the currently fabricated device that was designed and conceived at Auburn, and some of the printed passives in the bottom right of the slide. In terms of capabilities that we seek, we are seeking additive encapsulation companies which have either desirable CTE or CTE that can be modified as a part of the process itself. Interconnect companies that may have lower temperature alloys, solders, isotropic conductive adhesives, or anisotropic conductive adhesives, or dielectric companies that can have materials that are processed additively for this particular application. Thank you.
Thank you, Pradeep. Next, we have Nick Ginga from University of Alabama in Huntsville.
Hi, everybody. Nick Ginga from University of Alabama, Huntsville, in the Mechanical and Aerospace Engineering Department here. I would like to submit projects for topics 9.1 and also 9.6. I'm a new faculty member. I've not led a NetFlex project before, so that's an opportunity that I would like to pursue. And I'm looking for collaborators and team members to partner with on that. I'm interested in manufacturing and design of multi-layered, additively manufactured, flexible and stretchable electronics, specifically multi-layer structures such as additively manufactured through substrate conductive vias. These type of structures can be a source of reliability concerns when subjected to complex multi-direction and mechanical loads and high strains that they may experience during use. These type of structures, they can benefit from finite element analysis to guide their designs and provide overall reliable designs and successful 3D devices. So in my group, I have experience with finite element analysis of electronic packages and thin films and stretchable flexible electronics. We have traditional mechanical characterization equipment, such as uniaxial load frame equipment, like you see in this image here. I have it's capable of monotonic loading and fatigue loading and also in environmental chambers, and coupled it with 3D DIC as well. Along with this, the more traditional techniques, we've also developed some other techniques, such as the video that you see here. It's a radial stretch tester, and it's for stretchable electronics for testing them not just in uniaxial tension, but in multi-directional tension. And we've done this for thermoset stretchable polymers patterned with electrically conductive adhesive. So in the image there, that's what we're testing, is that material. And also we have it coupled with our DIC capabilities to monitor the strain on the surface while we're testing it, and also monitoring the change in resistance of the device. So ideally, trying to find other partners, either materials partners or manufacturers that could benefit from some of these testing capabilities and also modeling capabilities in order to design some more reliable multi-layer structures.
All right. Thanks, Nick. All right, we'll keep moving on. Now we'll go into topic 9.2, thermal management for power electronics. And we'll start with a team from San Jose State University.
Good morning, everyone. I'm Hugh Yong Wong. I'm an associate professor at San Jose State U. Before I joined San Jose State U, I worked in the industry, an EDA company for 10 years. So our expertise is in simulation from device, transistor level to circuit and package level. So we have highlighted a few of our capability. On the left, we are showing the co-simulation, thermal electrical co-simulation of gallium oxide, which is a novel material for ultra-wide bandgap device, in which we're doing this short circuit ruggedness testing. And we have not done that, but we can further couple with package level stress and thermal electrical simulation. So we think that we are pretty good at doing novel device. So we have done like diamond, gallium oxide, gallium nitride. So we think that we can apply this to flexible electronics. On the right top, we have this funding from DOE, which is to build a framework to do radiation hardness for TCAD, for SRAM. So we can perform from ab initio, like study almost every type of particle from muon to alpha particle to study their linear energy transfer, and it transport this data to the final element device simulation, and then further to a circuit, which is a full TCAD simulation of SRAM. We compare the performance of nanowire and FinFET in terms of their radiation hardness. And at the bottom right, we are also able to measure extreme environment as low as 4.2 Kelvin. And we want to highlight our expertise in performing hot carrier injection, MBTI negative bias, temperature instability, and other gate oxide reliability model. And we think that this is very important for flexible electronics also. So we are looking for collaboration to contribute our expertise in simulation, modeling, and measurement. Thank you very much.
Thank you. All right. Next is University of Delaware.
I'm Nathan Lazarus from the University of Delaware, and I'm considering putting together a team looking at printing a power system in package based on a concept of trying to use printed channels for high performance coolant using room temperature liquid metals, potentially combining that with metallization of printed conductors to do things like integrate heat exchangers, and then trying to combine that with power modules, including power transistors and integrated power passives such as inductors. I was before I joined University of Delaware, I was a longtime researcher with U.S. Army Research Laboratory in their power and energy group, and so I have a lot of experience in liquid metals, 3D printing, metallization, power packaging, and so showing a few of the examples on the right there. And I'm looking very much for corporate partners for scaling up some of these concepts. As well as looking for people that can assist more in the thermal modeling and thermal design of these types of systems. Thank you.
All right, thank you, Nathan. Next, we welcome back Pradeep Lal. Pradeep, you might need to unmute yourself again. There you go.
Thank you. I was struggling with that button. Believe me, I was. Thank you. So my name is Pradeep Lal with Auburn University. So this particular topic, we are contemplating putting a team together on hybrid electronics with high efficiency cooling structures under topic 9.2. The focus is on additive manufacturing of passive and active cooling solutions to allow a 3D heat exchanger. So we have some sizable capabilities here at Auburn to develop thermal solutions for operation in sustained high temperatures, specifically for automotive electronics. And so we hope to be able to leverage some of that body of work for advanced semiconductor packaging and integration of components under this particular topic. Previously, we have also worked on development of newer high thermal conductivity materials for high I/O packaging, generally packaging that is used in GPU type of applications in the automotive underhood. And we want to be able to leverage some of the packaging solution experience for the sustained high temperature operation in automotive and defense applications for this particular topic. So in terms of capabilities, SOT, we are really seeking additively printed thermally conductive dielectrics for this particular topic, high conductivity laminates we have a couple of solutions, but we want to make sure that we are able to incorporate others that we may not be aware of, and passive solutions for integration with FHE. Again, we do have 2 solutions that we hope to be able to propose with the program, but we want to see if there are any others that would like to be included in the program. Thank you.
Thank you. And then finally for 9.2, we have University of Notre Dame.
Hello everyone. I'm Yan Liang from Notre Dame. So here we are simply to propose to project 9.2 developing these active thermal management solutions using our printed thermal devices for cooling. So just some background about our technology. So basically, our device is a solid state cooling device. So we can produce very scalable device for cooling and without the need of any cooling fluid or moving parts. So we have been working on this technology for many years. You can see this from the chart here. We have produced these materials using a very scalable printing process, producing very high efficiency materials. So far, we have achieved higher ZT, higher TE cooling efficiency than the best commercially available materials in both P-type and N-type materials, which allow us to design and fabricate this efficient so much cooler. So you can see from the chart from the bottom right, we can achieve a very high cooling power density and also pretty large cooling delta T. This again, and then we can make this device to be from a few micron to a few millimeter or centimeter, allow us to manage the localized hotspot, which can be, I think, one big advantage compared with you cool down the entire chip. We can basically use this device, to selectively control and manage the heat from its devices. We are looking forward to collaborate with people to put together a proposal. Thanks.
Thank you so much. All right,
Nick,
let's move on.
Can I jump in for a second? Just a request for all of our future presenters. We have just about 20 minutes and we have 10 additional slides left. So if you could please make sure to be succinct and stick to no more than 2 minutes apiece, we'd really appreciate that so we don't run out of time.
Yep. Thanks, Scott. All right, we'll go move on to 9.3, which is thermal management for power electronics. So first is University of Maryland. Patrick? So sorry, this is reliable hybrid electronics for extreme conditions.
All right.
There you go.
Okay, so well, this one kind of could be either. So it's reliable hybrid electronics for extreme conditions, but it also has some overlaps with some of the thermal management power electronics. So it's a good segue. So this is based on work that we've done at the Cal Center and University of Maryland on developing high temperature transient liquid phase center materials for connection, 3D printing on flexible polymer surfaces, and the use of thermal vias in the past to provide one-dimensional heat flow in solid glass substrates. And so the idea is to use some of the new flexible glass and ceramic substrates to create some thermal vias in them in order to allow for heat transfer in the vertical direction, but thermal isolation in the planar direction. Then do some additive manufacturing of some interconnections on the top using our transient liquid phase center material, and then to create a power module device. And we would do full thermal and stress simulation for reliability. We also have a lot of expertise in accelerated tests for reliability. And so if you see on the right there, we have temperature cycling, humidity, drop shock, failure analysis, et cetera, capabilities at the university, which we would like to offer as well to the other team members. If they're looking for reliability services, we'd be happy to partner with other teams on demonstrating reliability at high temperature and harsh conditions, because we have a lot of expertise in that. And what we would need in our team members is some developers and or suppliers of the flexible glass and ceramic materials, and some electrical engineering expertise in designing a circuit that would be worthwhile on this system.
All right. Thank you, Patrick. We'll now move on to Ingenious Micro. Brian?
Hey. Yeah, so Ingenious Micro is developing an affordable multi-tool hybrid additive manufacturing system, and also a unified software to make the process from design through machine code much easier, and reduce the training burden required to operate and get reliable prints. We have demonstrated this with multi-layer ceramic and conductor processes, and in particular for ceramic chip carriers with integrated environmental protection. In the bottom, you see an example of the multi-tool carriage and the software dicing and slicing in both additive and subtractive, and then piecing all that together for to make the type of parts shown in the middle, which include low temperature ceramics, low temperature meaning up to 900 C, conductor inks and pastes, engineering polymers such as Ultem and PTFE. We have developed multi-material parts and electronics and demonstrated package survivability beyond 20,000 G. We've also integrated radiation hardening, thermal and thermal management, and also printed 5G antennas with no distinguishable performance drop compared to traditional methods. And then finally, adding printed wire bonds to connect chips to packages. So some examples are in the middle. And we also have experience with conformal printing as well as origami printing of RF antennas and high power MMIC interconnects in the bottom right. And we're looking to support teams and end users with multi-material prototypes and or software optimization to improve workforce training. Thanks. Bye.
Thanks, Brian. All right. And finally, for 9.3, welcome back, Pradeep Lal.
Thanks, Nick. So this particular topic, we are really focusing on high G, extreme wide temperature reliability for FHE devices. The intent is to demonstrate high reliability and survivability in very high G applications, high vibration applications, both at extreme high and extreme low temperatures, and to be able to develop meaningful test durations, test levels for standardization of fully functional manufactured circuits. The intent here is to quantify the failure modes mechanisms, develop acceleration factors through experimental testing on a variety of different applications subjected to high G electronics, as would be expected in both automotive and in defense applications. So the center here at Auburn has done a lot of foundational work over the last couple of decades, and we have contributed to the development of shock standards that are now widely used in industry. And some of the earlier foundational work was all done here, those of you who are familiar with us. And so what we want to be able to do as a part of this particular program is scale up some of that earlier learning for the purpose of FHE. Capabilities sought, we are looking for companies interested in migrating existing designs to FHE solutions for harsh environments. Accelerated testing companies, we are partnered with a couple who would have solutions that are scalable specifically for FHE devices, and OEMs, first or second tier companies with interest in risk mitigation with use of FHE technology specifically for high G applications. Thank you.
Thanks, Pradeep. All right, we'll move on to 9.4, conformal and structural integrated hybrid electronics. We have Ethan Secor from Iowa State University.
All right, thanks, Nick. So I'm Ethan Secor at Iowa State, and our main interest in this topic area of conformal printing is really in the workflow and computational tools. So we have some toolpath software for conformal electronics where we can effectively take a curved 3D surface, try to flatten it out, put our 2D toolpath or circuit design on that, and then map it back to the 3D surface. And with a doubly curved surface, you're always going to have some distortion, but we have some ability to control the distortion here and actually tailor where that's going to occur on the object, which is something we're really interested in exploring. So a note there is that while we work mostly with aerosol jet printing here, the tool path capabilities are a lot more general than that. And so we're interested in potentially extending that to other deposition methods. In the middle, we do also have some, as I mentioned, conformal aerosol jet printing. Here we're using a robotic arm print head for that. So it's something that could scale to printing on large surfaces because all the motion is in the print head, or potentially in confined areas. And our focus is really on the manufacturing challenges here. I am not the right person to do any circuit design or antenna design or testing on the back end. And so what we're really looking for in partners is probably realistically companies that could lead more on that circuit and antenna design, give us some challenging and relevant demonstrators that'll push us forward in the core manufacturing capability development. Thanks.
Thanks, Ethan. All right, we'll move on to 9.5, which is the additive process for improved environmental sustainability of electronics manufacturing. And we'll have UMass Lowell.
I'm Gwen Streck, and I'm partnering up with Jasmina Burek. We're both from UMass Lowell, and I am a materials person and part of the printed electronics research facility here on the UMass Lowell campus. We're very well equipped. We have 5-axis NScript and aerosol jet printers, among a lot of other tools. We do materials work, we do RF testing. But I am partnering here with Jasmina because she specializes in sustainability models and a lot of other things, including hierarchical cluster analysis, techno-economic assessment, and even circularity assessment. So we're not here to lead a project. We're seeking an industry partner to lead the projects and provide the technology demonstrator and the facility to transition the process. We're just here to support your 9.5 idea and help make it more sustainable and help with our additive facility. And yeah, I think that's about it. And you can get more information about PERC using the link at the bottom, and more information about Jasmina and I and our contact info at the bottom of the slide.
Thank you, Gwen. All right, and finally we have 9.6, which is the open topic for new project leads. And we will start with Bayflex Solutions.
Yep. Is the slide moving on? Okay. Hi, we're Bayflex. We tend to support, not lead. We're a small little group. And these are 3 considerations maybe to top up your particular interested subject. The first one is what we call Bobby, and that's about disseminating information using secure AI that seeks the latest test methodologies, but also shows you exactly how to go about doing it. That's project number 1. Second idea is something that we call Leonardo, which is the ability to figure out how to discover qualification methodologies using machine learning that detects anomalies using a single sensor, multiple sensors, or images. It depends on how far we can get with that, but that could be exciting for someone, not only just us, but also for someone else. And number 3, when it comes to the realms of extreme environmental conditions, we've done a lot in this field by integrating mechanical testers and data analytics. I think the area that we're missing is more in terms of imaging and sensors. But for your consideration, we can also, I think there's a need to develop some kind of test methodologies for standardization for what I would call outdoor weather conditions based upon mil-spec 810H. So that could be interesting for someone else. We made updates on all of these things in the last 24 hours on LinkedIn, so you can actually see most of these concepts working. And we look forward to hearing from you. I yield back. Thank you.
Thank you. All right, next we have Biosensor Solutions. Carl, are you there?
Yeah, can you hear me okay?
Carl
Kalin from Biosensors. Okay, so we're a spin out of University of Colorado, Boulder Experimental Electronic Manufacturing Lab. And what you see here are some organic sensors. Now, the ones on the left go in laboratory test automation systems for growing experiments, and the one on the right go in the field. What do I mean by organic sensors? Yeah, they're polymers with carbon. They're basically variable resistors. And what we're looking for is partnership to help manufacture these things. Right now, they're all made by hand. We've had hundreds of them go on in laboratories, get really good results, but we haven't had success yet in being able to automate it with screen printing. So the cost gets down to a few dollars a piece. So what's the upside here is that this is the world's first and only streaming digital data on living systems in the ground. And we've been funded by ARPA-E, which is part of DOE, and NSF to develop super low cost environmental sensors that can help determine what processes actually work for carbon sequestration in the billions of acres of agriculture and rangeland. These also have the potential to be pathogen detectors for like E. coli, listeria. So ultimately, you may see when you buy a package of lettuce, you might have a little sticker on there. If it's green, go eat it. If it's red, return it because it's got listeria. And we don't want humans to be the sensors for these things anymore. So yeah, we're looking for people who can help us manufacture. I'm an outlier here, I suppose. It's a new sensor technology that just that we licensed a patent from Greg Whiting's lab, who has some background with you folks. So we're looking to discover how we could team up with whoever wants to make the next billion sensors. Thank you.
Thank you, Carl. All right, next we have University of Dayton and UDRI. Allison, are you there?
Hello, can you hear me now?
Again, yes.
Sorry. I'm here with UDRI and the University of Dayton. And our concept really combines a few novel technologies. The first of which is additive flexible substrates. These are novel materials that we've developed in-house and can print on commercial DLP machines, ranging from flexible self-healing components to high-temperature flexible materials. The second novel technology is Element, which is a liquid metal ink that we are partnering with UES, now a part of Blue Halo Company. They have a blade-coated version and an aerosol jet version coming out that we are combining with our ultra-short pulse laser capabilities here at UDRI to activate that ink with 5+ axis control. And this combination of technologies really unlocks unique manufacturing and assembly options. And that laser control and aerosol jet control we have with the ink and lasers allow us to manipulate those conductive traces in unique ways. You can see in A, B, and E how we've used the self-healing flexible substrate with the conductive ink, showing not only self-healing capabilities of the substrate itself, but also the ink to restore capability and mechanical properties. And images B and C show our laser workstation activating and controlling that ink however we would like to. Our partnership objectives are really to find an end user for this application. We've tossed around a few brainstorming ideas of where this technology can go, from inspection devices and blind bays to inflatable antennas and soft sensing devices. So if you're interested in any of these technologies, either combined or individually, we're open to discuss more.
Thank you, Allison. Next, we have Tony from Boise State University. Tony?
Hi, everyone. The topic we're proposing is multi-jet nanoparticle ink. We are trying to create a library of nanomaterial inks that are cross-compatible with the multiple jetting platforms, including aerosol, inkjet, plasma jet, and electrohydrodynamic printer. So our expertise is in scalable synthesis using sustainable processes. We make our inks based on water-based reactive inks, and also our inks are suspended in water-based inks. And we further tune we have expertise in rheology optimization, printer optimization, and developing low-temperature sintering inks. As you can see on the left side, it's a gold nanoparticle inks that can be sintered under 100 degrees Celsius. Similarly, we have previously worked with NextFlex and other members in developing devices, printing devices using commercial and also in-house developed inks. As you can see on the bottom right, we have worked with flexible hybrid electronic devices, printing and integrations as part of our sustainable route to print in substrate, we have developed inks that can be sintered using paper-based substrate as a decomposable devices. And we have identified some potential partners with Boise State, Oregon State, and Influx Lab. And you can find more information about us. And we are looking for any kind of collaborations. We can contribute to ink development or contribute to supplying inks or participate with other teams. Thank you for your time.
Thank you, Tony. And finally, let's move on to Iris Light. Chad, go ahead.
Yep, and you guys can hear me okay?
Yep.
All right, yes, thank you. Chad Husko, founder and CEO of Iris Light Technologies. So what our company does is we make an active photonic ink made out of a inorganic semiconductor. And the last few years, we've just been working on improving the quality of the ink. Specifically, it's one material and devices. So actually, we're in the long term looking to do a lot of optoelectronics actives. The technical gaps that we're addressing here are technical gap 3 from the materials group, active materials for printed sensors, and then related to that, long-term stability of these inks. This also goes over to components. Again, I mentioned we do that as well. And so the main thing here we're looking to develop, right, is we have the ink-based technology, we have the component technology. We're looking largely for someone who wants to really drive the sensor use case. You know, again, we have a few in mind that where we've heard from people about commercial uses, but again, we'd rather take an existing one that you already know as well. Printing partners, we have done some statistical studies. You'll see on the right-hand side here, like, demonstrated variation, within a run, and it's also across multiple runs here. So, starting to get that initial manufacturing data, but we really want to push this to higher levels, right, up the chain to get it more manufacturable. Encapsulation, would love to talk to people about that. The way we do things now is workable, but we'd like to get further. We're open to you leading this topic, but again, I guess this is the open topic, so we're supposed to lead as a new person as well, but unless you happen to fit that criteria. Yeah, I think, again, it's really important to distinguish. We have stronger TRL, MRL with our inks. The components depends on what it is, because we got a lot of different libraries, but I think, we've studied the stability over time of these things. People always worry about new inks and, how long the devices work and so on and so forth. So here's some data on the upper right there about the stability over time. We have created the inks, packaged them, wire bonded them, done the characterization all in-house for the optoelectronics as well. In the lower right, you see an example of a kind of near infrared photoconductor device we made. We're funded largely across SBIR funding and private investment. Next things we're doing as a company, working on accelerated lifetime testing of the devices and making more advanced circuits out of these things. So.
All right, thank you, Chad. All right, thank you everyone who participated in the teaming event, and those still listening in. So feel free to go ahead and reach out to the contact information on those potential proposers that they've included. These slides, as well as the recording of this Proposers Day and teaming event, will be made available soon on the PC9 website. That will be your source for all the documentation. And just as a reminder, please go ahead, if you're interested in proposing, go ahead and schedule a pre-submission consultation, or any questions that you might have, please go ahead and direct to proposal@nextflex.us. Scott, do you have anything to add before we close?
I'll say thank you to everybody for participating. Very excited to be, to have launched PC9 and to have the opportunity to talk with you all in the pre-submission consultation phase of PC9. There was a question that was asked about slides from the teaming event that do not have contact information. If you presented a slide and it doesn't have your contact info and you'd like to add it, please just email an updated version of the slide to us at proposal@nextflex.us. And we will replace the slide with the one that has your contact info. Otherwise, if you saw someone present and you'd like to get in touch with them, but you don't have their contact info, you can reach out to us at proposal@nextflex.us, and we will help put you in contact. Thanks again, everybody. Nice job, Nick.
Thank you, everyone.